this video, we are going to discuss about R-2R ladder type DAC. So, what is the disadvantage of the binary weighted resistor type DAC is it uses a wide range of resistors. So therefore, the fabrication of the resistor also is a big problem when the number of bits is increased. Okay, so therefore, here we are going to use only R and 2R resistor. So R value of resistor, it ranges from 2.5K to 10K. Okay, only these two resistors only we are going to use. So let us discuss the circuit diagram of this R-2R. So here also the input is given to a inverting terminal only. Okay, the non-inverting terminal is grounded. Okay. So this is VR, and from VR it is given to a. So here let me assume 3-bit DAC. Okay, 3-bit DAC. So it is either connected to a switch, okay, which is either it is connected to ground or it will connected to this point. Okay. It may be either the switch, either it is connected to this point or this point, or this point. Okay, so here this is MSB and this is LSB. Okay, this is the inverted version of inverted R-2R ladder. So inverted R-2R ladder, this one is LSB and this one is MSB. Okay, so it is connected to a R-2R resistor. So in between this one, I have a resistor. And that value is R. Okay, R-2R instead of R, you have to connect 2R. Okay, for the last value. So this switch, it is connected to B3. Okay, B2 and B1. Okay, so if I assume the signal called if I want to get if I want to convert to just 001. Okay, so here B3 is your LSB and B1 is your MSB, right? So if suppose I have given like this again. Yeah. So it's nice. Yeah. Okay, let me assume this is a signal we are passing. This is a binary value. Okay, so we need to convert that one into an analog value, right? So if B3 is connected to 1 means which means it is connected to this one, and the rest everything is connected to ground. Okay, this is how it is. So let me redraw this diagram. Okay, so here you have VR, and from VR it is connected to 2R, right? And the rest of the 2R is connected to the ground, right? And here you have R, and this is also R, and this is 2R. Okay, this is how the connection is. Okay, so I need to find the output at this point. Okay, at this point. Copy that. So here you can see this 2R and R is in series, right? This 2R and R is in series, so I can redraw it like this, right? 2R, 2R, R, 2R. Okay, so this one is 3R. Okay, so now you can see 3R and 2R is in parallel. Okay, so 3R into 2R divided by 5R. So you will get 6R, 6 by 5R. Okay, so now again I am going to replace this diagram like this. Okay, this 2R, this 2R, VR, this is R, and this is 6 by 5 R. Okay, so 6 by 5 R is in series with R, so you will get 11 by 5 R. Okay, so I can again redraw this diagram like this. Okay, so this is VR, and here you have 2R, and here you have 2R. Okay, and this is 11R, 11 by 5R. Okay, so now 11 by 5R is in parallel with 2R. So I can write 22 by 5 R square divided by 10, 21 by 5 R. So you will get 22 by 21 R. Okay. So I can redraw the circuit as R, VR, and this is 22 by 21 R. This is 2R, right? So if I want to find the voltage at this point, so at this point the voltage is so VA is equal to the total voltage is VR divided by 20 into 21 by R divided by 22 by 21 R plus 2R. So if I solve, I will get VR 22 by 21 R and divide by 42. So on solving, I will get 22 VR, RR get cancelled, and this one is 64. So you will get 11 by 32 VR. So I have find out this value is nothing but 11 by 32 R. Okay, that is this point, 11 by 32 R. 11 by 32 R. Okay. So if this point is 11 by 32 R and this point I want to find, right? This point I want to find. So that is nothing but I can term it as VB. So what is VB? VB is equal to 11 by 32 into 6 by 5 R divided by 11 by 5 R. Okay. So 5 get cancel out, 11 and cancel out. The R and R cancel out, then so you will get 6 by 32. 6 by 32, that is nothing but 3 divided by 16. Okay, so this point is nothing but 3 divided by 16. So this point is 3 divided by 16, this point is 3 divided by 16. So this point is 3 divided by 16. So if this point is 3 divided by 16, what is this point? And this is VC. Okay, so VC is equal to 3 divided by 16 into 2R divided by 3R. So if I solve 3 get cancelled out, you will get 1 by 8. So this point is now VC is equal to 1 by 8. So at last what we have found out, there is nothing but VR into 11 by 32. VR into 11 by 32, and this one is VR divided by 8. Okay, so if this is the case, you will get at this point the output does nothing but let me assume this is VC. So the VC value is nothing but VR by 8. Okay, so now if I assume I'm going to pass the signal called B1, B2 and B3 is equal to 100. Okay, so here the MSB is connected to, now the MSB is connected to VR, rest everything is connected to ground. Okay, so what happened if this condition occur? Okay, so let me redraw the circuit. So here 2R that is connected to ground. Okay, so here you have 2R, R, and this 2R is connected to ground, right? And this is R, and this 2R is connected to VR. So if that is the case, what is the value? So if I solve this one, this 2 is in parallel, so I will get R, right? So this is R. Now this is also R. So we'll get 2R, R-2R and VR. Okay, so this is 2R. So this 2 is in parallel, so we will get R. So I am going to replace this one by this is 2R and this is R. So R in series with R. Okay, this is how the circuit is. So finally what you will get, I need to find the point at this here, that is VC. So what is VC now? VC is equal to 2R into VR divided by 4R. You will get VR by 2. Okay. So this point is now VC values. Now VC values VR by 2. Okay. So what is happening here? If B1, B2, B3 is 100, you will get VR by 2. Suppose if I have B1, B2 and B3 like this 0, 1, 0, what is the value of VC? VC is nothing but VR by 4. So it is the denominator is increasing by 2, right? So if B1, B2, B3 is 0, 0, 1, you will get VR by 8. Okay. And you can see so at this point I can read out the circuit like this, right? So the final values you will get VR by 2, right? VR by 2 in parallel with in series with R. The equivalent resistance is R. Okay, that is connected to the op amp like this. Okay. So for this value B1, B2, B3 is equal to 100, VC value is VR by 2 and the equivalent distance value is R. Okay. So if that is the case and here the input resistance, the input is given to the inverting terminal. So I can write V0 is equal to minus VR by 2 into RF by R. Okay. This is a case for 100, right? Then B1, B2 and B3 is equal to 100, right? So what will happen when B1, B2, B3 is equal to 111? Okay. So I can write V0 is equal to minus VR divided by 2 RF by R for 1000. So if for 010 it is nothing but minus VR divided by 4 RF by R, right? For 001 it is minus VR divided by 8 into RF by R. So if I take minus RF divided by R common, okay, I will get 1 divided by 2 plus 1 divided by 4 plus 1 divided by 8. Okay. So this I can write it as minus RF divided by R VR into 2 power minus 1 plus 2 power minus 2 plus 2 power minus 3. Okay. This is a case when B1, B2 and B3 is equal to 111, right? So I can write this one as RF by R in order to find the overall equation 2 power minus 1 B1 plus 2 power minus 2 B2 plus 2 power minus 3 B3, right? This is your V0. So divide the equation by 2 power 3 on both sides. Okay, multiply and divide the whole equation by 2 power 3 on both sides. Okay, you will get minus RF divided by R into VR by 2 by 3, that is equal to 2 power 2 power 2 B.
It's worse than anything is power.
2 power 2 B1 plus 2 power 1 B2 plus 2 power 0 B3. Okay. So I can write this one as minus RF divided by R VR divided by 2 power n is equal to B1 2 power n minus 1 plus B2 2 power n minus 2 plus and it will goes on till Bn 2 power 0, right? So this is the equivalent circuit. How to write this one? So I can write minus RF divided by R VR 2 power n summation I is equal to 1 to n, right? Bi 2 power n minus I. So if I equate 1, this is 3, right? This is 3. So if I substitute, I can see V1 2 power 2, that is 3 minus I is 2 plus B2 2 power 1 plus B3 2 power 3 minus 3 is 0. So this is your equation, final equation.